Today I want to present about the reactions of metals and acids. My presentation divided into three parts. The first is theoretical, the second is method, and the last one is reaction between metals and acids in the real life and in the lab. Now let's start with theoretical. Metals are elements that react by removing valence electrons to form positive ions. After that, it combines with negative ions to form ionic compound. In the reaction of metals with acids, there are two factors affecting the composition of the reaction product, such as the activity of metals and the concentration of acids. Take a look at the reactivity series of metals. It is clear that in the reactivity series, metal decrease chemical reactivity from the top to the bottom, and the metals above hydrogen will react with dilute acids such as hydrochloric acid and sulfuric acid. However, the metals below hydrogen will not react. The second point is the characteristic reaction of dilute acids and metals. Acids react with metal and the product is salt and hydrogen. This is a single displacement reaction where the anion from the acids recombined with the cation of metal to form the salts. When acid reacts with metal, will produce salt and hydrogen. In this case, hydrogen and chloride forming magnesium chloride, and hydrogen gas gets released. Let's move on the method. In the procedure, we start experiments by adding 1 mole hydrochloric acid up to 1/3 of the small tube. After that, dropping 1 strip of magnesium in and placing the large test tube over the top of the small one to produce gas in the large one. In the small test tube, the bubbles floating to the surface and had the fizzing sound. We left the test tube for a few minutes and it became warmer and the magnesium became smaller. To explain for this reaction, the magnesium was dissolved in hydrochloric acid to form magnesium chloride and hydrogen gas. Therefore, a chemical reaction has taken place. To test the presence of hydrogen gas, we put a lit match into the large test tube neck. The flame burned stronger and the pop sour appeared. Hydrogen gas is highly flammable and the exposure to flame would be produced a pop sour as the reaction of hydrogen with oxygen in the air in a small explosion. So in the safety precaution, there are some noticeable in these experiments. Firstly, the magnesium ribbon is a flammable solid. Secondly, the hydrochloric acid is a corrosive liquid. And finally, the hydrogen gas is explosive and flammable gas due to static electricity. So we did this experiment very carefully. Before conducting the experiment, we had to wear the safety goggles and gloves. We know that we had to hold the test tube and the lit match away from ourselves and carefully keep distance between flammables and flame. Additionally, we used the small quantities of metal and low dilution of acid. The final point I want to present about reactions between metal and acids in the real life and in the lab. The lead acid battery is so common in our life, especially in the battery of the car, of the motorbike, or in the electric bike as well. The discharging of lead-acid battery is a redox reaction which converts the chemical energy into electrical energy via the reactions of lead dioxide, and sulfuric acid. In the battery, have two electrodes containing anode electrode and cathode electrode. The reaction between metal and acid occurs at the anode electrode. At the anode during discharge, lead is manufactured by the giving up two electrodes of a lead atom and combined with sulfate ions produced from the dissociation of the hydrogen ions from the sulfuric acid to form lead sulfate. In addition, the reaction of zinc and hydrochloric acid to form zinc chloride, which is used as deoxidizer and the catalyst in the lab. In conclusion, the acids react with the most metals to form a source and hydrogen. Only metals above hydrogen on the reactivity series will react with dilute acids. However, the metal below hydrogen will not react. And the hydrogen pop test can be used to confirm that a chemical reaction has taken place between an acid and a metal.